So my name is Vinod. I work at Twitter, and I'm also a committer on the Apache Mesos project. I've been working on this project for about 2 years now. So it's been a long road here. I'm glad to see that so many people are interested in Mesos, and you came to this talk. So this talk is going to be about how you go about building a framework on Mesos, what it entails. And then I'm going to talk about a case study of a recent framework that we built. We're just trying to port Jenkins onto Mesos. All right. So I'm going to start with a very brief overview of what Mesos is for those of you who are new to this. So a Mesos cluster typically consists of a leading master and a bunch of slaves. The slaves are the hosts in a data center, and we have Mesos slave daemons running on the host, one per host. And for high availability, we typically use more than one master, even though only one is active at a time. And Mesos uses Zookeeper for leader election between the masters, and it also is used by Mesos slaves for discovering master. It could also be used by frameworks. So Mesos by itself in a data center is not really that useful. You need to run something on top of it to actually get the power. And so in the Mesos world, we call them frameworks. So you could imagine a Hadoop scheduler as one of the frameworks, which runs its tasks on Mesos slaves in this execution context. The nice thing about Mesos is you can actually run more than one framework. So multiple frameworks can actually run on the same cluster and efficiently utilize the resources. So you could get more buck or more efficiency out of the bucks you spent on the cluster. So let's kind of dig deep into what a framework is and how does it look. So a framework consists of two parts. The first part is the scheduler, and as the name suggests, it's responsible for scheduling jobs or tasks. It primarily receives resource offers from Mesos. The resource offers are CPUs and memory and disk available in your cluster, and it's going to use them to launch tasks. The second component is executor, and its responsibility is basically to execute the tasks that the scheduler wants to launch on the slave. And the Mesos slave actually launches the executor for you when you launch a task. And I put a star next to it because it's strictly optional. We do have a default executor called the command executor. So if you just want to run an arbitrary shell command, we can actually just wrap it and run it for you. So you can only build just a scheduler and get away with it. To kind of visualize this, let's imagine you have a master and a slave with 10 CPUs and 2 gigs. Once it connects to the master sends an offer for that slave to the schedulers that are connected to it. And let's say if the scheduler has some work, it's going to launch a task. So task is a very abstract concept in Mesos. It's like a unit of work that uses some resources. So let's say it wants to launch a task that needs 2 CPUs and 1 gig of RAM. It's going to send it to Mesos. It's going to get routed to the right slave. And the slave is going to figure out if there's an executor already running for this task. If not, it's going to launch one. And then it just passes on the task to it for it to execute. So let's dig a bit even deeper on what does it mean to write a framework. How do you go about writing one framework if you want to write one? So Mesos makes it really easy to write frameworks. We provide APIs in C++, Java, and Python. You could actually go and look up our example frameworks and source examples for C++, Java, and Python frameworks to see how we do this. I think more importantly, there are a lot of open source frameworks that you could look up, and all of these are either built or ported to Mesos, built on top of Mesos or ported to Mesos in different languages. Synchronous was from Airbnb, and you guys all know about Apache Hadoop. And dpark is a Spark implementation in Python. So they all run on Mesos. So let's look at the scheduler. So in Mesos world, a scheduler has again 2 components. The first thing is called callbacks. You can imagine callbacks as a way for Mesos to inform scheduler about stuff. For example, there's a callback called resource offers. Clearly, this is when Mesos wants to send offers to the scheduler, this callback is going to get called. Similarly, there is something called status update that gets called, which I'm going to talk about a little bit later in the talk. And there are a bunch more. I urge you to look up our documentation to figure out what all these callbacks mean and how you want to implement them. And the other side of this is actions. So you could imagine actions as a way for the scheduler to actually tell Mesos about doing some stuff. So you have things like launch tasks, to launch tasks in the cluster, or you can kill the task if the work is done or you're not interested anymore, or if the offer itself is not interesting, you could just decline offers. So let's look at an example of how it implement a resource offers. This is Java, and I pulled this up from our Jenkins scheduler that we built, which I'm going to talk a little bit later. Slightly modified to kind of make it look nice here. So you get a list of offers from the scheduler, from the Mesos, and then you loop through the offers here. And imagine you have a list of requests that are tasks that you want to run on the cluster. You see if the request matches your offer, and if it matches, you create a task, which essentially calls launch tasks action, and then it goes on to Mesos and magic happens. Similar story on the executor side. Again, you have callbacks and actions. You could probably see a parallel between the callbacks of executor and the actions of the scheduler for obvious reasons. So you have launch task on the executor and kill task. And the actions are executor could actually send status updates back to the scheduler or framework messages. So I'm going to talk a bit about what status updates are and why they're important. Oops. Okay. So status updates are a way for the executor to inform the scheduler about the state of the tasks. We typically classify them as terminal or non-terminal updates. Non-terminal updates are like task running, for example. And terminal updates are when the task finished or failed or killed or whatnot. We also have a special status update called task lost, and this is generated by Mesos itself. When something happens in the cluster, it's unexpected, like if the slave crashes or if the executor crashes, we can inform the scheduler with a task lost message. And I say this is really important because when you write an executor, it's really important for you to send a terminal update, because that's the only way Mesos would know that you have done using those resources. If you don't send a terminal update, then those resources are going to be charged to you. So you definitely want to send the terminal updates when your tasks are finished so that you get the offers for those resources. One last thing before I switch gears, a couple other things actually for you guys to keep in mind when you write a framework. Mesos is nice. It's all asynchronous, kind of makes it easy to write your scheduler. But the thing is, you kind of have to be a little careful. The first thing is the callbacks are single-threaded, which means you only want to get one callback at a time. This translates to you not blocking in a callback and trying to expect other messages from the driver or Mesos, which you're not going to get unless you return from this callback. So don't ever block in a callback. The other thing about actions being asynchronous is that when you send an update, for example, which is an action, and it returns, doesn't necessarily mean the update is sent out to Mesos. It's probably just queued in the driver. So just keep that in mind when you use actions. All the messages are queued up and sent in due time. So that's all I wanted to say about framework and writing about frameworks on Mesos. Now I'm going to switch gears and talk about a recent port of Jenkins that we did for Mesos and how we built the framework for this. So the motivation for this is pretty simple. Typically, Jenkins clusters, most of you know Jenkins people use for CI, and they're typically very small and statically allocated. And at least at Twitter, they're order of magnitude smaller than our compute clusters. And capacity planning is really hard. You either statically allocate a really big cluster, or you allocate a very small cluster. It's kind of hard to figure out what the right number of nodes are. If you overutilize it and the Jenkins cluster is always busy, your jobs are going to get queued up in the Jenkins, and it's going to take hours. I know on Apache at least it takes up to like 10 to 12 hours at a time to get your build, get an executor to run on Jenkins. And on the other hand, if you underutilize it, it is of course wasting a lot of resources. I pulled this up from Apache's Jenkins yesterday. This is a graph of how the load looks on the Jenkins master and Jenkins cluster actually. So the blue line here is the total number of executors running in the cluster, and the red line is the ones that are actually doing some work, and the gray ones are the ones that are actually waiting to get an executor. As you can see, it's definitely not zero. There are always at least 15 jobs that are waiting for an access to an executor. So this is a clear case of underutilizing the cluster, sorry, overutilizing the cluster. And I've looked at the cluster, the Jenkins cluster at Twitter, and it's on the other end of the spectrum. It's completely overutilized. It's probably an order of magnitude overutilized for its workload. So we said, okay, how do we solve this? So we said, make Jenkins elastic, which means auto scale based on the load. Like if you have load, launch more slaves. If you don't have load, kill them. And also we said, why not harness the compute clusters that we already have here? We already spend money on it, and we have a lot of idle resources in those compute clusters. Why not use that and share it for Jenkins? I mean, that's the whole point of Mesos. And one nice thing to have is like resource monitoring of your Jenkins slaves. Like if you don't know how much memory and CPU Jenkins slaves are using, it's kind of hard to do capacity planning. So it would be nice if you can get this information. So with this in mind, we actually built a framework and ported this on Mesos. So the way we did this is we wrote a scheduler, and this implemented as a Jenkins plugin. So you could actually just hopefully soon go to Jenkins plugins repo and install this and able to run it on a Mesos cluster. So it launches Jenkins slaves based on workload and kills idle Jenkins slaves when there's no load. And this is one of the frameworks where we actually didn't write an executor. We just used the default command executor to run jobs. It just wraps the Jenkins slave shell script and runs it. To kind of visualize this is how it looks. We use something called a cloud API that Jenkins provides. So this basically hooks into the job queue of the Jenkins master and lets our scheduler know whenever there is load and could use an extra slave. So when we get that signal, Jenkins scheduler launches a Jenkins slave, and it gets launched by the command executor. And once it's launched, it just connects to Jenkins master via JNLP, which is what Jenkins supports. And at this point, it's completely, the communication between the Jenkins slave and the Jenkins master is completely out of band of Mesos. For Jenkins, this is as if it's running, it's connecting to a slave, and it could run jobs on it. So if it wants to run a Jenkins job, it just sends it over to Jenkins slave. Once it finishes, it's going to get the results back. So everything is completely magically done according to Jenkins master viewpoint. How do you install the plugin? So getting the plugin is actually pretty easy. Right now it's hosted in the Mesos repo itself, but we might be moving it into its own repo on GitHub soon. All you need to do is like make Jenkins, and it builds a plugin for you. And installing the plugin is you could just go to Jenkins web UI and upload the plugin from your hard drive. Or if you're command line inclined, just copy the plugin to Jenkins home plugins directory. If you do this, you probably need a restart of the Jenkins master. And the configuration is pretty simple. You just go to /configure page on Jenkins, add a cloud, give it the address of Mesos master. And all those jobs that you want to run on Mesos, you can just label them as Mesos, and it's going to run them on Mesos. So I'm going to show a demo, but I just want to say the caveat that this is just an experimental release, so don't try it in production. But definitely I'm hoping some of you guys would, after this talk, test this out, and we could improve this as a community. make it a first-class framework. All right, let's do the demo. Okay, I already built the plugin. So I'm going to just start the Jenkins master. So Maven gives you an option to actually start the Jenkins, local Jenkins directly from the plugin repo using Maven HPI run. All it does is it starts up a Jenkins and it already installs the plugin for you. So this is nice for prototyping and demos. So let's, while it's starting, okay, let's also start a Mesos cluster. So I'm going to start a Mesos master. So I'm just going to create a local Mesos cluster with one slave and one master. So that's the master. And let's start a slave and connect it to the master. All right, so that looks good. Now let's hop on to Jenkins configure page. And let's also open Mesos page. Okay, so I just directly went to the configure page on Jenkins. As you can see, you have a new option called add a cloud. You add a Mesos cloud here and just give it, I can't even see, localhost 5050. That's where Mesos cluster is running right now. And there's some advanced options if you want to set the resource usage, but we have some sensible defaults. And let's just save. And this should hopefully connect to a Jenkins, connect to Mesos. As you can see here, from the Mesos UI, Jenkins framework has connected to it. So we're good to go. So let's launch a job. So creating a job, let's say demo. Oops. All right, and all you need to do is label it as Mesos, and then let's run a dummy job. Hello, okay. We save this. So I'm going to now press build now. So what should happen is our plugin should recognize that it has run on Mesos, and it should provision a Mesos slave and Mesos task, and run a Jenkins slave on it, and give it the job. So I did press build, and as you can see, it actually spun up. Not clear from here. It actually finished already. It's too quick. Mesos is too good. So as you can see, it launched a Jenkins slave, and we call it Mesos-Jenkins and some UID. And if you can actually look up Mesos web UI and see the slaves, you can actually see that there's a task running. Probably not from this page. If you go from the frameworks page, actually see a task running, which is actually a Jenkins slave. And to make sure it all worked out, it's actually blue, so it means it worked out. You can actually confirm by looking at its terminal output. So finished, success, and there's a hello world. So it sent back the results to the Jenkins master, so everything went as expected. And if you actually wait for a while, you could actually see that it's going to kill the slave after some idle time, but I'm not going to wait for it for this talk. That's pretty much all I had. Cool. I think this is time I could take some questions if you have any. So the question was, how do you, what's the guidelines for running an application on Mesos and whether we could use this? I think totally. So depending on what kind of applications you're running, there are different kinds of frameworks that you could use. Like if you're running map reduce jobs, for example, you could use Hadoop scheduler that runs on Mesos. And if you want to run some generic jobs, if you want to run some cron jobs, for example, you could run Chronos, which is a framework that runs cron jobs. And if you want more general processing, general purpose frameworks, there's not one out there yet, but we have one at Twitter we're going to talk about soon in one of the lightning talks. So, and that's open source, you could actually use that to also run your applications. So any application that could actually use multiple slaves to make it faster could be actually used in the Mesos world. And I think the nice thing about Mesos is that if you have different kind of frameworks tackling different responsibilities, that's totally cool, and you could do like efficient utilization of resources in Mesos. So the question was, is there a way to integrate Jenkins jobs with containers in Mesos? Totally. It all depends on how the Mesos cluster is set up. So currently, when you start up the slaves in Mesos cluster, you actually say what kind of containers, or whether you want to use containers or not, and that decides whether any jobs that come to the slave are going to be containerized. So you don't have to do anything on the Jenkins side. When you bring up Mesos slaves, just there's a command line flag saying isolation is C groups, which means the slave is going to use C groups isolation. So any jobs any tasks in Mesos world that are launched on the slave are going to be containerized. So in this case, the Jenkins slave is containerized in one container inside Mesos slave. So it's not going to affect other jobs that are running on the slave. So the question was, what is the thing called filters in one of those callbacks one of those actions that we showed. So filters is a feature in Mesos wherein you could say, when you get an offer and you're not interested in those kind of offers, let's say you're getting offers from slaves that are too small for your tasks, you could actually say, don't send those offers again for like next 1 hour. I don't have jobs for those. So you could actually set some filters. Currently we support only time-based filters, as I said. So when you get a resource offer, you could say, oh, I don't need this for the next 1 hour. I don't have jobs that satisfy this, so don't bother me with those resource offers.
But specifically, why do you pass the filters when you're actually scheduling a job? There's like the third parameter in there, I think.
Yes.
And that, if you're not declining, but you're actually scheduling something, why would you filter?
So when you send a launch task, you might not be using all the resources in the offer. For the rest of the resources, it's going to say, oh, this offer ID, don't send anything back. If you don't need the whole offer, you can just say decline offer. But if you're using some resource and the rest of resources you don't want for a while, you could just say, use this filter and don't send me this offer for this time. So the question was, if the slave has certain attributes and you want to make your scheduling decisions based on it, how do you go about it? Luckily for you, actually support this out of the box. So there's this option called attributes on the slave itself. So when you start them, you could say, oh, this box has SSDs in it, or any random attributes, like just a key value pair, anything that you want to do, you could just set the attribute on a slave. And when you get offers, the attributes are actually inside the offers. So you could actually base your decisions based on the attributes of that offer. Okay. Sure. So the question was, what are the efforts for packaging Mesos for people who don't want to build it from the source? There's actually a lot of activity going on very recently for packaging Mesos. I don't know if you're already on the mailing list, and I don't know if you're one of the guys who are talking about it, but so we're definitely really aware of this problem, and we're definitely interested in solving this. And there are definitely efforts, like for example at Twitter we use RPM to build Mesos and distribute it to our clusters, and we want to definitely generalize it. And there's already efforts out there for building an RPM, like making scripts to build RPMs and deb packages, and hopefully someday like Homebrew, just use Homebrew to install it. So there's definitely efforts going there, and we're actively supporting it, and we definitely want it out there. That's definitely on one of our roadmap. It's one of the items on our roadmap. So the question was, how are containers enforced? The resources in containers enforced. So currently we support CPUs using CPU shares. So we use C groups in Linux. So what CPU shares gives you is basically guarantee the minimum CPU that you could use. So for example, if you request 2 CPUs, you're guaranteed to get 2 CPUs off the box. But if the box is idle and the box has 10 CPUs, you could actually use more. We're actually adding support for strong guarantees, because it's one of the requirements at Twitter too, and some of the other people outside Twitter in the community to have like strict guarantees. So we use something called CFS, which basically makes it the maximum CPUs that you could get. So if you ask for 2, you're only going to get 2, even though the box is idle. This is useful for things like if you want to do capacity planning and you want to have like deterministic idea of how your application behaves. This is something that you could use. The code is on the trunk. It's still experimental, I would say, but definitely give it a whirl. We're also going to test it at Twitter pretty soon. On the memory side, we have a hard cap. So if you go out of memory, you're going to get oomed and killed. You're going to oom and we're going to kill you. We also thought about giving some soft limits on memory side too, so that we give you some grace period to kind of do some memory constraining on your side too, instead of just hard killing you. But that's not it's not been worked on currently. That's something that we have been talking about too. Cool. Okay, they asked me to cut it out. All right, thanks guys.